Okay, so this is about area and the perimeter. So area tells you how many units square here in this particular example. If one side is 2, other side is 3, 2 by 3, 6, and you count how many units square there, that's 6. That's the geometry meaning of the area. The perimeter is different concept. The perimeter is that if you use a fence to include this region, then just how long you need it, how long a fence you need. So the perimeter is 3 plus 3 plus 2 plus 2, total is 10. Right? So 10 depends on the units you're using. And this is going to be 10, which is the perimeter. Okay. So that's the geometry meaning of the perimeter. If you use a fence to put around that region, rectangular region, then how long the fence you're going to use. Okay, so that's called the perimeter. Now, of course, the area is not necessarily to be integer. Sometimes it could be a fraction. Okay, so let's take a look at the next problem. Okay. Okay, so this is this side is 3, here's a 4. Okay, so for example, this rectangle, right? And we can, sometimes rectangle 2 different shapes, we still can have a same area, but the length would be different. Okay, so the parameter will be different. So this rectangle, let's look at another one. Okay, so this side 2, here's 6. So look at this 2 rectangle. Okay, both have the area, same area. It's going to be 12, and this side of the area is going to be also 2 times 12. So if you are given this 2 type of a piece of cake, and even one is longer, other one is shorter, but they should have the same area, so it's quantity the same, no difference if the thickness of the chocolate, for example, is the same. Okay, so that's about area, but clearly the other one is longer. So as you can see that the perimeter of this one is going to be 3 plus 7 times 2, right? 3 plus 7 plus 4, which is 7. So it's going to be 14. And it could be 14 inches, could be 14 feet. Okay. The other one is going to be 2 plus 6 multiplied by 2. Sorry for, yeah. So you will see that 2 rectangles, they have the same area. Okay, but the parameter is different. Okay, 2 times 8, that's going to be 16. Okay, so if you want to build a fence around the rectangular region area, on the right hand side, you need, for example, 16 feet long fence. The one on the left, you only need a 14 feet long fence. But that do include the same area. Area is a very important key point, because how many vegetables you can plant depends on area, not depends on the length or the width of the region, right? So get some idea about area and the difference between area and the perimeter. Okay, so both have the same area according to the formula, but they have the different perimeter. Now, if you draw them into, if you cut them into many squares, and you will see there are 1, 2, 3. Here you count the 12 unit square here, and here you also get 12 unit squares. Okay, but just put them in different order. Okay, right? So those two rectangles that do have the same area, but they have the other one has a longer parameter than the one on the left-hand side. All right, so let's take a look at some examples. Okay, let's take a look at some examples. So if a rectangle has an area of 18 times 30 square meters, the length is 36 meters. Now, what is the width? Okay, so you are given the number, but this number is written as a product. Okay, so how do you solve this problem? Step one, you draw the picture. Okay, this is rectangle. Okay, draw a rectangle. This side is 36, and we don't know the width. Okay, use a W. Okay, use W. So the area of this is going to be, right, 36 times this width. We don't know what is that, right? And this is supposed to be 18 times 30. So basically, you're trying to figure out that number so that the product of this number with 36 is going to be 18 times 30. Now, if you rewrite, 36 is double of 18. So maybe you can write it like this, 2 times 15, right? So this will be 36. Okay, that's a quick way to solve, find the W. So that is going to be 36 times 15. Okay, 36 times W equals 36 times 15. W should be equal to 15. Okay, right? So you get 15. Or you can also get, by divide both sides by 36, then use a calculator, just do the computation. You still get 15. Okay, you divided both sides of the equation by 36. Okay, yeah, got it? And because sometimes you're not lucky, you're not able to, write a 36 times some number on the right-hand side. So you still can, you write down this extra first, then maybe get a decimal, for the width. That's possible. All right, so, but anyway, this is geometrical problems. You do need to draw the picture first before you write down any, kind of a equation, so-called, right? Got it? Okay, so let's take a look at the next problem. Okay, a rectangle has a length of 54 meters, width of 30 meters. If the length is decreased by 18, by how much is the area decreased? Sorry, this is the area will be decreased, yeah, not increased. Yeah, the area is decreased. Okay, so the length is decreased by 18. Okay, look at the picture here, right? So this side is 30, this side is 54. 18 is this piece. Okay, so you're going to lose how much of that? Yeah, that's my hint. Are you able to solve this problem? All right, so look at this, right? You draw the picture, you cut off the piece you lost, right? So that's a piece we are going to lose, right? Ethan, watch out. Okay, So you're going to lose this piece. So it doesn't matter how long the original length. Okay, this is a piece you're going to lose. So the area, yeah. So area of that piece is going to be 540 square meters. Okay, right? So decreased by 540 square meters. Clear? Yeah, this is part, you shorten the length, then you're going to lose some region, some area. And that area is just, 18 times 30. Okay, the width is still there, it's the same width. Okay, so width the same width. Okay, so that's what they got. Okay. All right, so take a look at the next problem. The length of, let me move it up a little bit. If the length of the rectangle is increased by 10 meters, then the area is increased by 100 meters. What is the width? Okay, that is inverse. That's a little bit more complicated than previous. We don't know the width. But you draw the picture, okay? You draw the picture, that helps you a lot. Of course, the width is not changed. The width is not changed, but the length is increased. Okay, the length is increased. Okay, so that is the width, right? That is the length. So the length increased by 10 meters. So this is the part is increased part. The area is going to be the increased part. The area is going to be 100, right? Yeah. So 10 times W should be equal to 100. Right? So W should be equal to 10. So 10 meters. Okay, got it? Yeah. So as long as you draw the picture, it's clear. It's easy to see. If you don't draw the pictures, confused. So step 1 for geometry problem, always draw the picture. Okay. Okay. All right, so the next one is a little bit complex. I draw a couple of pictures here already. So I will like to try. If the length of the rectangle is increased by 5 meters, while the width remains unchanged. So just look at, so width is remain unchanged. Then the area is increased by 100 meters. Okay. Now, if the width is increased by 5 meters, while the length is unchanged, then the area is increased by 100 feet. Either this or that, right? In either two cases here. So what is the area of the original rectangle? That's just two-step problem. You have to find the width and the length of the original. Okay, clear? It's the same, just double the walking road than of the above problems. Okay. So please work on this. Clear? Yeah. For the first first piece of information given, you can figure out the width, then you can figure out the length, then you solve the problem. Okay. So first one is the length is increased by 5 meters. 5 meters. Okay. Here, the length is increased by 5 meters. But the area here increased by 100, right? Square meters. And this one, the area is increased by 150 square meters. Okay, right? Yeah. So you can figure it out using each of the picture. You can figure out the width and the length. Okay, anyone else? I haven't get one answer from a student. I wish at least 6 students give me answers if you're able to enter your answer here. Okay, remember this is W, right? This is L of the original length. So 5 times W is going to be 100. So what is W? W is going to be 20, I think, right? 5 times 20 is going to be 100. Then the other one is the 5 times L, the width times length is 150. So L is going to be, I think it's going to be 30, right? So therefore, the area of the original rectangle is going to be 30 times 20. So it's 600 square meters. Okay, 160 square meters. Right, so that is the answer. Great. So we do have some students solve the problem. I'm very glad to see that. Now, don't be shy, okay? If you get answers, just tell me. You don't need to show to everybody. So yeah, don't need to show to everybody, okay? Right. So you see that, don't post it to anyone. Okay. Thank you. All right, so now here's another problem, okay? A rectangle has a perimeter of 30 meters. If the length is 7 meters long, what is the area? Oops, okay. Now, this is a two-step problem. Let me show it to you first. Let me show you how to do it, okay? So this side is the width, this side is the length. So the length is going to be 7. The length is going to be 7. We don't know the width, okay? So the parameter is going to be 2W plus 2L, right? So 2W, I don't know, but 2L, I know that's going to be 2 times 7, which is supposed to be 30. So we trying to figure out what is W, okay? First of all, 2W plus 14 equals 30. This is a simple equation we have to solve. You subtract the 14 from both sides, right? And you will get, okay, here's 16, right? So the width is going to be 8, actually. This is not exactly the width, it's longer than the length. But anyway, so that is 8. So once you get 8, then you can get an area. Area is going to be length times the width, 7 times 8. So it's 56 square meters. Okay, clear, right? That's two-step problem. And you are given the perimeter. So you write down the formula for perimeter. And the length is given, the width is unknown. Then you try to figure out what is the width, okay? Using that equation. And that should be equal to 8. So 8 plus 7 times 2, it's going to be 30. All right, so now I'm going to ask you to do the next problem, okay? The length of the fence is on 3 sides of the rectangular garden is 700 meters long. If the length of the one side is 150 meters long, what is the area of the rectangle? What is the area of the rectangle? So you draw the picture, draw the river, okay? Okay, so draw the river, and you put the rectangle here. Okay, one side you don't need to put the fence. Okay, you have 3-sided fence. Okay, and so you're given information of the length. Can you figure out the area of this rectangular garden? Well, you draw the picture first. I'll help you draw the picture right now, okay? What do you need to know? You need to know the length of this rectangular garden. This is a two-step problem, yeah. You have to find the length first before you find the area. Right? Yeah, you have to find the length. But if you draw the picture, you will see that how do you figure the length, right? So width have two pieces here on the left and right side. The length is only one piece. Right? The length is only one piece. So the width, the length of the one side means that's actually 150, right? 150 plus 150 plus the length is going to be 700. So this is 300, 700. So L must be equal to 400, right? L is 400. Okay. So L is 400, then you find the area. Okay. Why L is 400? Because this is a 300. 300 plus 400, 700, right? So the area is going to be length times the width. L is 400. Width is 150. 150, right? So 150. Okay. So that's going to be, and then we have, yeah, 60,000 square meters. Is that true or not? Right? Yeah, 60,000. I think 60,000 is correct answer, and not everybody got the same answer. Okay, so this time. Yeah, let me repeat again. The picture usually is not given. You have to draw the picture. You draw the river and then draw a rectangle. And then you mark it, two sides use W's and the line parallel to the river is denoted by L, right? Then you have to look at the problem again. What is given? Given is the width. Because if the length of the one side of the length is 150. I think this is a weird sum, right? Now there's you may argue with me, well, this could be in the middle, right? Yeah, it's really not very clear. One side, how many sides? 3 sides there. If that is the case, maybe the answer is different. Okay, maybe the answer is different. So think about this, right? If this is one is the length of one side, you have 3 sides of the rectangle, got it? If this side is 150, then you don't know the width, right? Then probably get different answers. So W, 2W plus 150 is going to be 700, right? Then 2W equals 170, 700 minus, 700 minus 150 is 550, right? Then from here, W, you divide by 2, so 550 divided by 2, right? Divide by 2, 275. So now area is going to be L length times W. So 150 times 275. You get totally different answers, yes. 275 times 150. So 41,250 square meters, right? Do you think it's possible from my reading, just only one side? So I don't think, unless you can say the short side is going to be 150, okay? One of the short side, the short side, then probably the first one is answer. Otherwise, you can even have 2 answers, argue, right? Yeah, one side. That's the 2 possibilities, one side. Okay, this could be the side parallel to the river, right? Could be parallel to the river. Then the picture maybe looks like that, not like a very long one. It's going to be it's going to be a short one. It's going to be like that. 150, right? And then 275, 275. That's possible. Why not, right? In that case, the area is going to be 41,250 square meters. All right. So that's to just be careful about, about the problem, different, so we, in this particular case, I don't see which side. Yeah, it's not clear. The short side or the longer side. They're both are small, right? 150, 150 also smaller than 400. Yeah, the side, if the side is perpendicular to the river, is 150 meters, then the solution will be the first one. Okay, if this side is parallel to the river, then the second solution is the correct answer. All right, so now we do the similar problems, okay? So the length of the three sides of a rectangle, the length of the three sides, the total length of the three sides, okay, is going to be 64 meters. The length of each side must be integer. What is the largest possible area? Wow. The total length. Okay. So this is a mini maximum problem. Okay. So how do we solve this problem? Well, I don't know. It's L plus 2W equals 64. The area is going to be L times W. So we want to make L times W as large as possible. Okay. So if it's a rectangle, not three sides, four sides rectangle, then the largest area, largest possible area is going to be the area of the square. Okay. But here it's only three sides. Okay. How do we solve this problem? I think we should guess and try. I think you begin with the length is half of 64. We try this. Make a table. Okay, make a table. So L could be half of 64. Begin with that. Okay, begin with this. So L is half of 64. Okay, then you calculate W. Then let the value of L change, right? So look at this, right? So L is going to be L is going to be 32. Okay, let's try this. If L is a 32, W is going to be, okay, you make a chart, okay? W is going to be 32 divided by 2, right? Is going to be 16. Then the area, okay, the area is going to be, right, 32 times 16. It's 512, okay? Then you increase the length, but clearly you cannot use L must be even number, because if otherwise W, you cannot find an integer for the W, okay? So if we increased L, okay, so L is 34, and the W is going to be, okay, right, 34 and 16, so W is going to be 15. And you will see that the area is going to be increasing. And it's decreasing, yeah. So that's 110, okay? Right? Yeah, 110. So when L equals 36, Okay, W is going to be 14. And area is going to be 36 times 14. So it looks like you are going down, right? The area, we want to find the largest possible area. So I think we should go the opposite direction, right? So this stop here because it's going down every time, right? So let's try L equals 32, decreasing the length. Okay, 30, yeah. W is going to be, right, 17. Okay, so let's see. 30 times 17, it's going to be also 510. See? Yeah, L equals 29, and not 28. W should be equal to 18 because 28, 64 minus 28 divided by 2 is 18. Now, 28 times 18 is going to be 504. You see, so it looks like we're lucky. You know, this is going to be the largest possible value you're going to get. Okay, the both are going down either way on both sides, right? Yeah, when L is a 32, and this gives you largest possible area. Okay, so the answer is what is largest possible area? Is the 512. Okay, right? You can try different values. You know, then if we choose if we increase the length, you decrease the area, then you have to give up and go in the other side. Increase the length and to see if you increase the area. Yeah, that should be a maximum value you can get for the area. Okay, which is 512. Okay, so when L is 32, W is 16. So actually you get two squares here. Yeah, 16, 16, 16, 16, so total 32. Okay. All right, so this is a slight different problems, and we have to find the maximum value, okay, of the area. Now, let's try the next problem. As a square pool has a sidewalk of width of 1 meter. If the area of the sidewalk is 400 meters, what is the parameter of the square pool? Okay. So this is a square. Okay. We also have the sidewalk. Okay. The sidewalk is 1 meter. Okay. That's a square. The area side, we know the area sidewalk. We have to find out the parameter of the square. Cool. So this is A. Okay. This is A. So we have to find A. If we know the area of the sidewalk. So the area sidewalk gives you the information of the length. Okay, who can figure it out? You have to do some cutting, okay? All right, let's do this problem. Okay, think about how do you find the area of the sidewalk? You cut them into many pieces. Okay, so this is a corner, right? And the corner is a square. Okay, so let's calculate this area of the sidewalk. The area of the sidewalk. Okay. The area of the sidewalk will be, it consists of four rectangles. Each rectangle has area A times 1, and they have a four of them, right? And plus the area of the four corners, square corner. So it's going to be 4, because 4 times 1 times 1, that should be equal to 400. Okay. So from here, I can get A. Right? I can get A because 4A equals 4 equals 400. So 4A is actually going to be the parameter of the square already. So 400 minus 4, 396. 396 is the correct answer. Okay. Okay, this is a problem. You can also do the problem directly. So you look at you try to find the area of this one piece, one piece of that. It's the same piece, right? So the total area, the total area 400 minus the area of 4 squares divided by 4 is against the area of one rectangle on one side. Okay, and that is going to be 396. But that is the area of the one rectangle, yellow, in yellow color, a rectangular sidewalk, right? Okay, so then because the sidewalk, the width is this rectangle, the width is 1, so 8 times 1 is, it's going to be 396. Okay, but I prefer to set up equation like that, and then you solve for A. Okay, A is the length of the square pole. Okay. All right, so the next problem, I draw the picture here. 4 identical rectangles, as showed to you, with the width of 2 feet, form a square of the area of 81 square feet. What is the area of the inner square? So I'm talking about inner square. This is the inner square, right? This is the inner square. Okay. Okay. Let me know if you can figure it out. Anyway, okay, we got a couple of different answers. So form a square of area for 80. So this is this total, right? This is A, okay, right? So A square is going to be 81, right? To form a square, I'm talking about square, including the inner square, okay? 81, so A is going to be 9. Okay, now if A is 9, right, then how do you find the length the length of the inner square, the side length of inner square, right? So this square, to form a square of area, that does not mean the area of these 4 rectangles have area 81. I'm talking about the square they are formed. Okay, form a square. The square that formed is going to be has an area of 81. So the side length of the square, okay, the side length of the square is going to be 9. So this is a square we're talking about. Okay. Okay, so that's why it's 9. Okay, so it's 9, and then once again 9. Now can you figure out B, right? Because look at the picture here. This is there's 2, right? The width. So here is also 2. So B is going to be 9 minus, oops. Just a second. I'm bringing the picture. No, don't worry. It just closed. Right? Okay. So B is going to be just use a subtraction, right? And the C, here's a 2, here's a 2. So 9 minus 2 minus 2. You only have a 5. Okay. So that's why the area of the inner, the inner square is going to be 5 squared, which is 25. Clear?
Or it could be A minus, the B equal could be 9 minus 2.
No. Just look at the picture. You have 2 sides here. The total is 9. The length on the one side.
Yeah, so if it's like 9 minus 2, it could also equal 9 minus 4.
Yeah, equals minus 4. Yes, so, but the B is 5. Okay. Yeah, the B is 5. It's a square feet. Yeah. All right. So I said that draw the picture. Definitely have to draw the picture. If you cannot draw the picture, you cannot figure it out.
I draw it on the picture.
Okay. Yeah, depends how they understand the problem. Somebody understand the problem is the inner square area is going to be.
And use the same strategy as you so I can understand it.
Okay. Yeah. So I just want to emphasize that this form the square means this larger square, not the square inside. Okay. Otherwise, you don't need to find it. It's already know the area of the inner squares if you say it's 81. Okay. So I'm talking about, yeah, the square formed by those 4 pieces, the largest square. Okay, so here's another problem. The side length of the largest square is 3 feet longer than that of the smallest square. Okay, the difference of the area is 39. What is the area of the smallest square? Okay, clear? You have 2 largest square. and the largest square, okay, is 3 feet long. The side length is 3 feet longer than the smallest square. Okay, but I also know the difference of the area is going to be 39. So I already draw the picture, show you, give you some hints. Okay, I wanted to find the area of the smaller square in the yellow color. Okay. Okay. So anyone has answers? I do have a, not yet. Okay, so look at the picture, right? I think the square, on the side is 3 by 3, it's 9. So all I needed to do is find the edge length of the smaller square. Okay. So what they do is 39 minus 9, right? This is going to be, you can calculate the total area of the difference. Right? You can calculate the total area of the difference. So how do you do that? Let's write down the equation for 39. Okay. So 3 times L is the area of that rectangle on the top, plus 3 times 3, plus 3 times L. Total is 39. That is the difference of the area. Okay. Okay. So now you get 3L, 3L is 6L plus 9 equals 39. So 6L equals 30. So L equals 5. Okay, again, if L equals 5, then the area is going to be 5 square is against 25 feet. Okay, 25 square feet. Okay, so now take a look at the next problem. The area of the shaded region is 300 square feet. What is the area of the small square? It's the same idea. Let me finish this. We don't have much time. It's the same idea. You see, so the width is 3 feet, right? So we have to calculate the total area of side region. Okay, so it's going to be, first of all, how many pieces here, right? 4 pieces, right? 3 times A is the area of a one rectangle like that. And then you have 4 of them, right? And the plus the area of the 4 squares. So each square is 3 times 3. So it's a 4 times 3 square. The total is going to be 300. Then you from here, you find the A. Once you find A, you can find the smaller area. The area is smaller square. Okay, so let's do it. You know, it's 12A plus, okay, my God. Yeah, so yeah, let's find out. So that's 12A plus, oh, something wrong with my software. Hold on. I have to be very careful, touch the screen. Okay, so 12A, right? You can solve it, right? And here's 49. Oh gosh.
Maybe you have something wrong with your keyboard.
No. Yes. Yeah, you can work on that. I already gave you the equation. Okay, you're trying to find it and find the A. All right, so let me finish this. 12A plus 36 equals 300. Then you solve the equation. Okay, 300 minus 36, and then divide by 12. And that is, you know, by step, then you have 300 minus 36, 264. Then from here, you can find, right? And you use, yeah, 254, 264 divided by 12, it's 22, right? So the area is going to be just square. So area is going to be 22 square, okay? 484 square feet. Okay. Yeah. All right, so the next problem is the area of the larger square is 400 square feet, and the area of the small square is 100 square feet. What is the value of the W, the width? We're trying to figure out the width. Okay, now for this problem, right? So you see the difference of the areas. So what is the best way to solve this problem? Okay, you already know the side, this side, 20, okay? Because 400 is gonna be 20 square. All right. And the inner inside, right? It's gonna be 100 is gonna be 10 square. Okay, so you can figure out the length of the inner square, right? The side length of the inner square and the side length of the outer square. Okay, so the W is going to be 20 minus 10. I think you have to divide by 2, right? 20 minus divided by 2, which is going to be 5, not 4. Yeah, 5. Okay, so you get 5. Okay, so this inside is going to be 20, right? So 10, 20 divided minus 10 divided by 2. Okay, so okay. So our next problem, it's probably the one of the last problem here. So we have the rectangle. Let's draw the picture, and then there's a width. Okay, 36 and 20. So if the length is decreased by 9 meters, but we want to increase the width in order to keep the same area, okay, the area unchanged. So what you should do is, I think this is a, yeah, this is a length. The length is already know that 36 minus 9, okay, is 27, right? 27. So in order to have the same area, and this part is going to increase part, right? Right, this part is increased. So the area of the new rectangle is going to be 27 times, I think 20 plus W, okay? Because the total length is 20 W. And that should be called 36 times 20, okay? Because that's the original area. So from here, you have to, you don't multiply this out. You can 20 plus W, that's the new width, okay? Including part. And then, and you divide 27. I think we can simplify it, okay? And here, this 3 has 3 times 9, and 4 times 9, and here's 20, so 9 canceled out. But I cannot simplify it further. So that is going to be 80 over 3, okay? So the width is going to be 80 over 3 minus 20, and then this is a subtraction fractions. So you have to combine them. And 20 is a 60 over 3, right? So actually the difference here, 80 minus 60 is 20 over 3. So this is, that's okay, you know, keep it a fraction. I don't make it the integer. That's fine. So the idea is you just calculate the width of the new rectangle and then subtract the 20, then you get an answer, okay? The width of the new rectangle should be 80 over 3, okay? So, yeah, so this is the problem. This is the kind of problems, you know, we understand the width, length, areas. It's about the rectangles, right? And we are coming back to the geometry late, but this is all we needed to know about the rectangle at this moment, okay? The geometry, you know, we have a step-by-step level, and here we just learned everything. You know, in the future, we're gonna study triangles, you know, maybe even 3D geometry, right? Cylinders, spheres. But right now we just focus on rectangles, okay? The length and the width, and we should know how to figure out the width and the length and the area, okay? All right, so that's all about today's problems I discussed, and I hope everybody has a good weekend.